All right, well, this time around we're going to go through and we're going to determine the values for which a rational expression is undefined, and then we're going to go through and simplify some rational expressions. So let's go ahead and get going with a few of these. First off, if we want to go through and determine which, or I should just say, if we want to determine the values for which a rational expression is undefined, I first have to go through, take a look at the denominator, and figure out what values will make that denominator 0, because we know mathematically we cannot divide by 0. So taking a look at the very first expression that we have here, if we go through and take a look at our denominator, we have, well, what is it? 2b plus 5. And I want to set that equal to 0. So in order to go through and do this, of course, I got to subtract 5 from both sides. And I end up with 2b is equal to negative 5. And then divide both sides by 2. And I end up with b equaling negative 5 halves. So what that means then is that this is a value for which my denominator will be undefined because I can't have 0 there. So what we're actually saying is that b is not allowed to equal negative 5. For this example over here, I first have to go through and factor that denominator. So I know I've got, let's just put it right underneath. First terms in each are going to be x. Factors of 6 that add to give me 5. So the plus sign means that they're both the same. This plus sign means that they're both positive. So we're going to have plus and plus. And then again, factors of 6 that add to give me 5, well, that'll be 2 and 3. So then that means that the values here, what are the values for which the expression is undefined? Well, that would be if x is equal to a negative 3, or sorry, a negative 2 first, I mean that's the first one here, and then negative 3. So if I look at this, that means then x cannot be these values. All right, so when going through and trying to determine whether or not, or what values the expression is undefined, I set the denominator equal to 0, I solve, and those are the two values, or those are the values that it is not allowed to be. Simplifying rational expressions. So when we go through and simplify, we have to factor both numerator and denominator, and then once we factor that, we eliminate common factors. So like if I look here at this first example, or that middle example here, if I factor everything out, and I notice I have a common factor of x minus 9, well then the x minus 9's go away. They go away because of the fact that it's actually the same as equaling 1. So x minus 9 divided by x minus 9, well that's just 1. I don't need to write that. So therefore I can simplify this as far down as possible by getting rid of those two because they're not necessary. They actually simplify out to a factor of 1. So taking a look at this example, I'm going to have to factor both the numerator and the denominator. So my numerator, will set that up, 2 sets of parentheses. First terms in each, this tells me they're going to be x and x. This negative here tells me they're opposite signs. This negative sign tells me that the larger one is negative. So plus, minus. Factors of 2 that differ by 1. Well, that's only going to be 2 and 1. And we know that the negative is the larger. So the 2 goes there, 1 goes there. Now let's take a look at the denominator. Go through and set up our parentheses. First term in each is going to be x. Now I need factors of 2 that add to give me 3. So let's see, in this case I have a positive sign here, which means they're both going to be the same signs. And then this tells me that they're negative. So negative and a negative. Factors of 2 that add to give me 3, well, that's going to be 1 and 2. So now what ends up happening is I can get rid of these two simply because of the fact that they're the same. So since they're the same, I don't need to keep them there. So simplifying this, it turns into x plus 1 divided by x minus 1. Now, I'm going to point out over here, one of the most common errors that students make is they see an x in the numerator and an x in the denominator, and they're like, no, I can get rid of that. You can't do that. So you can't suddenly get rid of this and then say that it is minus 1. I can only simplify factors, and factors are when we multiply. I cannot simplify terms in the numerator and denominator. So therefore, this is as simplified as it can get. All right, let's take a look at this example over here. So I'm going to factor my numerator first. So by factoring the numerator, we got to set up our little parentheses. First terms in each are going to be x and x. All right, this says I have a negative sign, so it means I have a plus and a minus. And then I need factors of 32 that differ by 8. So factors of 32 that differ by 8, 2 and 16, nope, that's not going to work. 4 and 8, that works. So then the larger one is going to be negative. So 8 goes here and the 4 goes there. Down here, that's not quite in the order I like to see it. So I would rewrite this, negative x squared plus 64. But I don't really want negative x squared, right? I got to turn this into something I can factor easy enough. So I'm going to factor out a negative 1. And I get x squared minus 64. That is something I'm used to factoring. So I've got a negative 1 on the outside. Then I'll set up my parentheses. This is a difference of 2 squares. So remember, from factoring, a difference of 2 squares just means that I take the square root of the first term, take the square root of the last term, and they have different signs. So this means I will have x plus 8, and I will have x minus 8. So now I've got everything as factored as far as I can go, and now what I need to do is get rid of the common factor. So this is a common factor with this, so then I'm just left with what we have written here. I've got the x plus 4 in the numerator, I've got a negative sign, and I've got an x plus 8. We always want to bring that negative sign out in front of the fraction. So now I have negative x plus 4 divided by x plus 8. And I cannot simplify that any further because these are terms within the numerator and terms within the denominator. So I can't simplify that, just like up here, I'm not able to do that. All right, so that was going through and determining the values at which the denominator cannot be. So basically when we get into functions, it would be values that are not allowed in the domain. And then we went through and we simplified a few rational expressions. So I hope this was helpful, and have a great day.